So remember, first we have to identify what type of polynomial it is. If it is a binomial, we follow this. If it's a trinomial, we follow this. And if it's a polynomial, we follow this. So there are three different situations. I wouldn't say that they have nothing to do with each other, because they're not really. There is some overlap here and there. But this is how I would like you to think in terms of three different slices, and they have different. We treat them differently. We have different special products, and so on and so forth. Okay, so first I have to identify what it is. What is it? It is a trinomial. Is it in descending order? Greatest common factor to all three. To all three. To all three. No. Very good. Negative leading coefficient. No. So I'm hoping now for a special product. I always hope for a special product because that's the easiest. This is second easiest, and this is really the most difficult. Okay, so if a special product works, then I have only one option for the plus in the middle, right? So I'm checking to see if this is the one. So I do not look at the middle term. And what I see it's an x squared and a 25. So I expect this to be the case. But I have no clue, because I only looked at two terms. I have not looked at the middle term. So I can say that this is the correct answer before I check the middle term. And I know that when I expand this, I get three terms. I get a squared plus 2 times the first times the second plus the second term squared. So 2 times the first times the second will be 10x. Now, if this 10x is identical with the 10x from there, then only then I can say, yes, this is the correct factor form. A counterexample would be, let's say, x squared plus 7x plus 25. And it's very clear that this is x plus 5 squared, right? Because it's x squared and 25. But the middle term here is 10x. But the middle term here is not 10x. So obviously this is not correct. Is this clear? Other questions for me? Anything else? Okay, so let's continue with another example from these. Like, for example, with x squared plus 13x plus 36. Okay, please do not skip any of these steps. If you do, you may potentially make your life more difficult. Okay, first I have to identify which slice it is. Is it this one? Is it this one? Or is it this one? Yes, perfect. So it's a trinomial. Is it in descending order? Yes. Greatest common factor? No. Negative leading coefficient? No. Special product? I hope for a special product, always. These are the easiest ones to work with. You may not particularly like the difference or sum of cubes, but these are the easiest ones to work with. The rest is slightly more difficult. So I'm saying fine, yeah, honestly is easy, right? No problem. However, I did not check the middle term yet. What is the middle term here? 13. What is the middle term here? 12. Not just 12. 12x. Very good. Perfect. 12x. Is this 12x? So obviously this is not correct. So I have to try again. So since no special product works, I'm asking myself now, okay, so this is the next in line. Is 1 the leading coefficient? And the answer is yes. 1 is the leading coefficient. So I'm trying to find two numbers whose product is 36 and whose sum is 13. Excellent. So remember how we think. We always start with the product. The product is positive, so therefore there are two possibilities, both to be positive or both to be negative. But the sum is a positive number, so this makes no sense. I can't add two negative numbers and obtain a positive number. So then I'm looking for two positive numbers whose product is 36 and whose sum is 13. 9 and 4. Very good. 4 and 9, 4 and 9. Both conditions have to be fulfilled. 4 times 9, 36, yes. 4 plus 9, 13, yes. So then I immediately go ahead and factor this. Can anyone give us the factored form?
X plus 4.
Excellent.
X plus 9.
Excellent. That's it. Questions? Yes, please.
How do you on the trinomials, the bottom two?
Yes.
How do you differentiate between those two?
You mean the last two?
They look exactly the same like that.
These two?
Yeah.
So first of all, we haven't talked about the last one. So I cannot point out differences if I haven't talked about the last one.
Yeah, but like having one there is just the same as not having one there. So
Yes, it's that is specifically saying not one. That is specifically not one. So this is much easier, and this is the most difficult one. I saw another hand.
So we did the x squared. If on the test we do x plus 5 and x plus 5 instead of x plus 5 squared.
It's not incorrect, but we have to write it as x plus 5 squared. And the reason you're doing that is because you're not going through these steps. So once you go through these steps, you're never going to write x plus 5 times x plus 5. But again, I don't want you to change a habit that is good. I want you to improve on it. So I'm not going to, force anyone to use my method. I will never claim that my method is the best for everyone because it's not going to be true. So whatever works for you, keep it. You may want to improve on it a little bit. Perfect. Anything else? Okay, so now we are down to the very last possibility. So let's go and choose an example. And I want to caution you that we probably need 2 or 3 here. This is the most difficult possibility or option. Okay, so let's start with the first one. 6y squared minus y minus 1. But once you understand it, you'll never make a mistake. Okay. Go back to my strategy. I have to identify what it is. What is it? Okay, is it in descending order?
Yes.
Greatest common factor?
No.
Negative leading coefficient?
No.
Special? No, it's a 6. Special product? I hope. That's not possible on a special product. This is not a perfect square, and this is negative. There is no negative on the last term of a special product for trinomials. So once I see a negative here, I don't even need to ask myself special product. But I just want you to get into the habit of going through all the steps. So that's not possible, right? Now, I'm asking myself, is this the case with 1 as the leading coefficient? I wish. No, it's not. It's the very last one where the leading coefficient is anything but 1. Okay. So here are the steps for something like this. We are looking for 2 numbers whose product is, but this time the product is not negative 1. It includes 6. This is the product now. It's negative 6 indeed. So here it was exactly the same, but I didn't tell you. If you want 36 times 1. It didn't make any difference because it was 1. But here, negative 1 times 6, so it's negative 6. And then the sum does not change. What is the sum? Yes, that does not change. Remember, we always start with the product. The product is a negative number, so therefore I'm expecting a positive and a negative. Mandatory. Because I cannot multiply 2 negatives or 2 positives to get a negative number. So it must be a positive and a negative. Therefore, what do I do next? I have to find 2 numbers, 1 positive, 1 negative, whose product is this and whose sum is this. Very good. Negative 3 and 2, or 2 and negative 3, doesn't matter. Both conditions are fulfilled. However, you cannot write the answer at this stage. This is the next step. So be very careful. 1 is not the leading coefficient. You cannot use these numbers to factor like we did before. What we do is rewrite the problem. I replaced this term using these numbers that you just gave me. So this does not change. It's still negative y. Do not go back and combine them because you're going backwards if you do that. So now the next step will be we factor by grouping. So let's say we group the first two. Please tell me what you pull out from the first two. What is the greatest common factor?
3y.
Excellent. What is left in parentheses?
Y minus
Careful.
2y.
Yes?
Is
Perfect. What do I have to have coming from the other two? I know they're there because I found the two numbers whose product is -6 and sum is -1. What do I have to find in parentheses before I even look in order to be able to continue?
2y minus y.
Mandatory. First, please write it before you look. If these two are not the same, we cannot continue. Something is wrong. Only now I look. I need two things from you. I need a sign and I need a factor. What is the sign and what is the factor?
Plus and 1.
Very good. Indeed. So now what is common to this term and to this term that I have to pull out? That's it. And now what is left from the first term? And what is left from the second term? It will only take you 3 seconds, 4 seconds to check. 2y times 3y is 6y squared. Positive 2y minus 3y is negative y. And -1 times 1 is -1. Any questions in the back? Ladies, yes. Any questions? Any questions? Anything? Anyone, please. Any questions?
Said 3y plus 1.
You can write as 3y plus 1, but I have to pull out the common factor first. But it doesn't matter. 2 times 3 is 3 times 2. You can write them vice versa. It's the same thing. Any questions? Okay, let's look at another. 4x squared minus 4x minus 15. Please don't skip the steps. What is it? Is it in descending order?
Yes.
Greatest common factor, negative leading coefficient. Special product, I hope for a special product. Why? Right, it's negative. No, not here, because this one is, yeah. This is a perfect square, by the way, but this one is negative and is not even a perfect square. Okay, is 1 the leading coefficient? I hope for that at least. No. No escape is the last one. Okay, perfect. So then I'm looking for two numbers whose product is very good, and whose sum is, that's it. Since the product is negative, that's my starting point. The product is negative, I'm expecting a positive and a negative number. Okay, so let's find a positive and a negative whose product is -60 and whose sum is -4.
-10 and +6.
-10 and +6, perfect. -10 and +6. Please check and make sure that both conditions are fulfilled. This product, yes. Sum, yes. What do I do next? Please dictate the new form. Yes? Excellent. Excellent. And how do we call this? Next step. What are we trying to do now? Very good. Factor by grouping. So please tell me what you will pull out from the first two.
2x.
Excellent. In parentheses, please.
2x minus 5.
In parentheses coming from the other two, I don't care to look.
2x minus 5.
Now I care to look. Sign and factor.
Three.
Do you all agree with plus 3? Good. Common factor outside, which is?
2x minus 5.
Perfect. And in parentheses?
2x plus
Excellent. Great job. Do you think we need another, or can we move on to the last one?
2.
Yes, please, choose. You want to do the 5x squared minus 26x plus 5. 1 minute. Please work on it 1 minute. And in the meantime, I will take attendance. I met 50 more students yesterday, so I may not remember everyone, but I will. Always here. Blaze is here. Mary Kate is not. She told me. Elizabeth. Kali. Megan. So you're new. This is your first day. Okay, we need to
Yes.
talk at the end. Okay. Maddie's here. Tyler. Yes. Margaret. Hilda. Okay. Victoria is here. Krisa is here. Nicole is back. Sasha. Chris. Chris. Garrett.
We're here.
Right. Garrett. Hannah. Thank you. Lexi. Thank you. Caitlin. Yes. Logan. Thank you. Alex. Alex. Yes. And Becca. Great. Okay. Ready? Yes. Remind me? Yes, I said Chris. Yeah. But I think, let me double check. Okay, good. So trinomial descending order, yes. Greatest common factor, no. Negative leading coefficient, no. Special product, I wish. One leading coefficient, I wish. So I'm down to 25 and 26 with minus in front. So then
Negative 25 and
negative 25 and negative 1. The sum is indeed negative 26. The product is indeed positive 25. Can anyone dictate the next step?
5 minus 25x minus 1x plus 5.
Perfect. From the first two, in parentheses.
X minus 1.
I don't look. I will, but not now.
Negative 1 x minus 1.
X minus 5. And then minus 1. So then it's x minus 5 and 5x minus 1. Do you need anyone to tell you whether this is correct or not? No, you're just going to FOIL in 3 seconds and you'll verify that this is true, right? 5x squared, yes. Minus 5 minus 25 minus 26. Minus 1 minus 25 minus 26. Negative 5 times negative 1 is positive 5. Yes? Okay, so final strategy. We're talking about polynomials. And I hope that we put factoring behind us. Here's the strategy. Isn't this nice? Nothing. Just factoring by grouping. There's nothing else. But of course I have to go through the strategy, but there is nothing else. Okay, so let's try x cubed plus 2x squared minus x minus 2. Let's identify what it is. What would you say? It's a polynomial. Is it in descending order? Perfect. Greatest common factor to all four. Negative leading coefficient. Special product. There is none. Good. So then just go ahead. Now here's one thing that I want to mention. If you group them first and last two and it doesn't work, you cannot conclude that it's not factorable. You have to try to group these two and these two. And also have to try to group these two and these two. So be very careful. Okay? So let's try first and last. What will you factor out?
X squared,
Good. And what is left in parentheses?
X plus 2.
What will you see from the other two? Otherwise, I can continue. Yes. And now what do you pull out? Minus 1 indeed. You will factor out x plus 2. And then you have, good. But this is not fully factored. When we're asked to factor, we're asked to fully factor. So what will you do with x squared minus 1? You can go back to the strategy, right? It's a binomial. It's in descending order, blah, blah, blah. This, or this. Since it's minus, it's either this or this. And now you have to identify it if it's applicable. So, very good. That's why we studied binomials first. Okay, with this, yes, we will solve equations and so on and so forth, but this will be part of the course, so we can continue with this, or just when they pop up, we will use factoring to solve equations. Okay. Any questions? Now, if there is anything in here that appeals to you, yes, please, Victoria.
Does it matter which direction they're in? Like, could I have x squared minus 1 in parentheses?
Yeah.
with x?
Yeah, that's what I think Alex asked.
Oh.
2 times 3 is 3 times 2.
Yeah.
Doesn't matter. No, not at all. Okay, any questions for me? Okay, the first section that we have to look at is graphs and graphing utilities. I'm going to, yes, Garrett, you want to say something?
No, I sighed.
Oh, okay. So
Not very
please.
good at graphing.
No, it's not a big deal. Okay, here it is. So I just wanted to show I will illustrate with a graphing calculator almost every class. There is always going to be something that I show you with a graphing calculator. But for now, let's just pick a problem from section 1.1. Because you do have a section in my lab math. Why did they reverse them? I have no idea. So let's just look at a particular equation, and I'll show you how to graph it and how to determine a few things. So here's one. Let's say 18, 2x minus 4. So the problem, you're going to see in a moment. So this is problem 18. Y equals 2x minus 4, and the page is 102. I'm going to switch in a minute so you can copy that. But anyway, so the equation is 2x minus 4. So you go to y equals, and you will type into, and x is this key where you see x, t, theta, and n, and minus 4. Now there are several options for the window, right? You can create the window you want. Let's do the standard first. Under zoom, there are several options, and 6 is standard. What does standard mean? Standard means that you're going to see a graph, and the viewing window of the calculator will show you -10 for x to +10 for x, from -10 for y to +10 for y. That's the standard. Now let's say we want to change the viewing window, because it's possible some of the problems will ask you to change the viewing window in MLM. Okay, so let's say I want to see between -4 and 6 with a scale of 1. The scale means only sticks are at 1 unit distance. And let's say y minimum -8 and y maximum, let's say I wanted 4. Still the scale of 1. And then I click on graph again. So that's how I adjust the viewing window. Let's suppose I'm asked to find the x and y-intercepts of this graph. I can't find the y-intercept with a graphing calculator, but can I look at the graph and estimate and say, well, I'm pretty sure that this y-intercept is 0, -4. Can you estimate the x-intercept?
2,
I see cell phones in the back. Krista, please put it away. So please, everyone, please. No cell phones in my class, please. Okay. So I see here that it appears to be 2, 0, correct? Okay, so let's suppose now I can't really read it. Let's say I can't. So I'm going to go to second and calc, and I have several options here. Now, the option that I want to find that will help me find the x-intercept is the 0. So I'm going to write this down for you in a minute. I'm going to switch. X-intercepts or zeros of a function are the same thing. So I will click on 0 or go to 2 and press enter. And the graphing calculator is asking me to give it a portion or an area or region where to look for that x-intercept. Oh, well, I see it somewhere around 2 because my ticks represent 1 unit. I'm going to say between 1 and 3. So I'm going to say the left bound is 1, so it's put in a limit in there. And the right bound now is 3. So now the calculator knows that I'm looking for the x-intercept somewhere between 1 and 3. It's asking me for a guess, and I'll say, no, I'm not going to guess. I press enter again, and it gives me the 0. So the 0 is x equals 2, and of course, the function is 0. So the x-intercept would be 2, 0. So, yes?
So when it asks you for the right and left bound, you just press the number button on what number you want to
Yeah, I used 1 and 3 because I saw it was around 2. It could have been 1.99.
I just never knew you could just press the number button.
Yes, you press a number. It's asking you for the left bound. You can also use the trace
Okay.
and move the cursor, but you can also put in a number you want, because then you have to press several times. So if you sometimes you can see, or you know a number left of that, or sometimes it's easier to just trace. Yeah. Okay, so I think that if you encounter anything else in my math, whatever, please bring it to class and we'll work on it, okay? Yes? Okay. So now I would like to move on to, so this is what I wrote for you here. So we graphed problem 18 on page 102, y equals 2x minus 4, and the x-intercepts or zeros of a function mean the same thing. So now I would like us to go to review 1.2. Linear and rational equations. I wanted to say that, in my opinion, rational equations are anything but trivial. So they are not, I don't take them lightly, right? So please don't, it's a lot of work, and they have a lot of ins and outs. So let's take a look at the following equation. Let's say problem 10 on page 120, and that is twice x minus 1 plus 3 equals x minus 3 and parentheses x plus 1. If you have your book or your any source on your, the book on your calculator, on your cell phone, or if you want to pick a problem, I'm always happy to show the problem that students pick, always. Okay, ready? First I have to identify, like before with this. So I know what I have to do. I have to identify what it is. The same thing with equations. I have to identify what type of equation it is before I do anything. So then, what type of equation is it? I have to say that you're not wrong. Say it again.
It's only one coefficient. It's only one x.
So it is polynomial, it's true, but what type?
I just did math.
It's written right here. Very good. So it's linear. It's linear equation. Very good. So what do we do first? You're saying distribute. Distribute. Very good. We have to distribute. So let's distribute. So 2x minus
2.
Yes. 3. Yes. So the first step in this kind of equation, linear equation, is remove grouping symbols. That's our first step. We have to remove the grouping symbols, whatever they are. So then we have 2x minus 2 plus 3 equals x, and then very good. The next step, we have to combine like terms. Combine like terms. Do not move terms around. Do not do anything. Just simplify the left-hand side and simplify the right-hand side fully. So this will be 2x plus 1, and the right-hand side will be negative 2x minus 3. Would you agree with that?
Yes.
Everyone?
Yes.
Perfect. So now here's what I recommend. I know you've been taught to say minus minus or plus plus under both sides. Look, the easiest thing to remember or to proceed here is, so I prefer, it's not mandatory, but I recommend, I prefer keeping the variable on the left. So this is up to you. Keep the variable on the left hand side. Keep the variable on the left hand side. This is just a suggestion. So then I will have to move this term to the left. Therefore, I will have to move this term to the right. What happens when we move one term from one side to the other? Just the sign changes. Very good. Excellent. So then this was negative 2x here. When I move it to this side, it becomes positive 2x. So I'm adding it to 2x. So then I have 4x. But then I bring the 1 that changes into negative 1. So negative 3 minus 1, this becomes negative 4. And the final step is divide both sides by 4. So I get x equals negative 1. So this is the method that I recommend in solving linear equations. Are we okay with this? Do we need other examples, or we're okay? One more? Okay. Would you like to choose, or you want me to choose? Okay, I am going to choose 19. In 19, we have 20 minus. Yes, yes. We are in the same section, yes. So minus x divided by 3 equals x over 2. Okay, what type of equation is this? Absolutely linear.
It's still
Linear. Even if we see a fraction in there, it does not have x in the denominator. So it's still a linear equation. There is no x in the denominator. I would like to eliminate fractions. I wouldn't say it's a must, but I highly recommend it.
easier.
Yes. Eliminate fractions first. Perfect. So then what will I do? What number will eliminate all three? Okay? All three fractions at the same time. 6 will indeed. Perfect. So let's multiply everything, both sides, by 6. So we multiply everything by 6. However, what I preferred writing when I solve a problem like this, I prefer writing multiplying by 6 over 1, multiplying by 6 over 1, multiplying by 6 over 1. Here there is really no need. It's still 120. But here I will simplify first. I will not multiply. I will simplify by 3. So I get minus 2x. And here I will simplify by 2. And I get 3x. So you're multiplying two fractions. 6 over 1 times x over 3 and 6 over 1 times x over 2. But you simplify first. Always simplify before you multiply. We know that the fractions have to disappear because we specifically chosen 6 to eliminate fractions. So there is no question there. But it's always easier to simplify before you multiply. Now, we can move 3x to this side, but in this particular case, I only prefer to move one term. I did say here keep the variable on the left-hand side, but I didn't say it's a must. I said it's recommended. But in this case, it won't make any sense to move 3 and also move 120. So I will say 120 equals 5x, and then x equals 24. So this was linear equations. Topic of solving linear equations. Now let's look at something else. Like for example, 47, say page 120. Let's say 2 over x plus 1 minus 1 over x minus 1 equals 2x over x squared minus 1. And now you will see the first major application of factoring, solving rational equations. What type of equation is it? Of course it's rational. I just said it, right? Solving a rational equation. Why is it rational and not linear?
Because x is in the denominator.
Yeah, because it has x in the denominator. It's no way near the same. Way more difficult. Way more involved. Okay. So here's our first step towards getting the solution. Our first step is state restrictions on x or the variable. If the variable is y, then it's going to be on y. If the variable is b, then it's going to be on b. What does this mean?
It's whatever makes the denominator 0.
Excellent. How come that we did not discuss this here? How come that we didn't state restrictions for x? There is no denominator. There is no danger here. Excellent. Very good. Well done. So here's a question for you. 0 divided by 5. How much is this?
0.
Right. And how much is 5 divided by 0?
0.
Very good. You understand that if you divide 0 by 5 or you divide 5 by 0, they cannot be the same. If this is 0 and we know it's 0, I have $0 right here in my hand, and I want to share my 0 with 5 of you. How much will I give you? But when you divide 5 by 0, there's no number that replaces that. So we like to use this fancy word, but it really means it does not exist. I can't find a number that replaces this. It doesn't exist. Okay, so let's write a note. Division by 0 is undefined. Of course, if you write it doesn't exist, I'm fine. If you say there is no number that replaces it, I'm fine with that too. But we like to use undefined.
So those restrictions would be -1 and +1?
Correct. Very good.